Hi everyone, Grandma Charlie here, and today we are going to learn about the law of conservation of matter. In order to understand this phrase, we need to understand what the words mean. A law, when we're talking about science, means a rule that has been proven by experiment to be true again and again and again, and is accepted by most scientists in the world. Now, conservation in this situation means keeping the same. So this is the rule of keeping the same matter. Matter is anything that has mass and takes up space. It's the stuff the universe is made out of. And you may have studied that matter can get very, very small. The smallest pieces of matter are atoms and protons and electrons and mesons and other subatomic particles. Well, mass is related to weight. And so we can use a scale to investigate the law of conservation of matter. First, I'm going to put a potato on the scale, and it reads 3.8 ounces. Remember that, 3.8 ounces. And now I'm going to move over here to the side, and I'm going to cut up this potato into smaller pieces. But the whole potato is really here. I mean, we could put it back together again if we had some Gorilla Glue maybe, but that would add to the weight. So we're going to put it back over here and wait till that number settles. And there it is. It's settling on 3.8 ounces. So even though I cut the potato up into smaller pieces, it weighs the same. Its mass is the same. The amount of matter is the same. Let's try something else. Let's put some water, a bowl of water, and some sugar, a little jar of sugar, side by side on our scale. Now this is exactly 10 ounces. I'm going to take the sugar. We're going to perform another physical change by dissolving this sugar in the water, and I'm going to stir it, stir it, stir it. I'm going to wait until the numbers settle here, and you can see it is still 10.0, even though the sugar has gone from this jar into solution in the water. So that demonstrates the law of conservation of matter in a physical change. Here's another physical change. I have 3 ice cubes here. Okay, remember this weight is 7.4 ounces, but I'm going to go over to my microwave and I'm going to melt this ice. I'm going to put a lid on it so that when it melts, none of the gas that might evaporate escapes from the container. Put it on this way. Okay, and I'll be right back. While that ice is melting, we're going to perform a chemical change. This chemical change uses baking soda, which is a solid. It's a white powder. You know what baking soda looks like. Yes. And vinegar, which is a clear liquid, and we're going to make a gas. So we're going to combine a solid and a liquid and make a gas. I put a cup of vinegar. Some baking soda on there. I put a cup of vinegar into this bottle, and then I put 2 teaspoons of baking soda into a balloon that I fastened very securely with a rubber band and some duct tape, and I'm going to hold it here. Now, let's see how much that weighs in ounces. Okay, I need to reset it because it's telling me it weighs nothing. And make sure I've got ounces, which I do. Okay, so, 9.0 ounces. Now that's an easy number to remember. We will remember that as we watch this chemical reaction occur. Watch a solid, there's baking soda in the balloon, and a liquid are making a gas. Oh, how cool is that? It's 8.9. I'm watching. It was 9. It's 8.9, 8.9, 8.9, 8.9. Oops, I touched it. 8.9. Maybe we lost 1/10 of an ounce of this gas leaked through here and into the air because we have 8.9 and it was 9.0 when we started. Let's get our ice back. The ice weighed 7.4 ounces. I'm going to reset this. 0. Yeah. And hopefully we get 7.4 ounces. And we did. So we showed the law of conservation of mass, of matter, in 3 ways. When ice cubes melt, that's a physical change. The mass does not change. When we added the sugar into the water, that's another physical change. The mass did not change. When we cut up a potato, into 4 pieces. That's a physical change. The mass did not change. Now, when we did the chemical reaction, ooh, this balloon is getting cold. Oh. When we did the chemical reaction, our numbers went down a little bit. And I think, maybe I didn't have it in exactly the right spot. Let me see. Yeah, our numbers went down a little bit. And I think we had some gas escape. But it's almost exactly the same. Now, the chemical reaction that takes place here is this one. It's baking soda and vinegar combine to form a salt of sodium acetate in the water here and carbon dioxide. And that blows up the balloon. That was really cool to watch, wasn't it? Here's another way to say it. Our chemical reaction was vinegar plus baking soda makes sodium acetate and carbon dioxide. That was the chemical reaction. And we did lose 1/10 of an ounce of mass into the air because the gas escaped my seal here that I did with a rubber band and with some duct tape. But the amount of mass in the universe is the same. That gas just went up into the air. It's still in the universe. Nothing happened to it. The amount of matter in our universe stays the same through physical and chemical reactions. And that is the law of conservation of matter. Now this got cold to the touch. That is called an exothermic reaction. It gave off heat into the surroundings and the solution itself got cold. And so you can see how a chemical reaction can produce heat. That's an interesting bit of information to have too. Thank you very much for watching my YouTube video on the law of conservation of matter. Thank you. Bye, everybody.